I'm here.
Let's go.
It's Mrs. Klein.
And Mr. Creighton, and we're here with your last podcast, not only for this unit, but for the school year. It's on the scientific revolution. In the past podcast, you guys learned about the history of the scientific thought, and today we'll be talking about how a scientific revolution developed. As always, you guys are going to have some terms and names you need to know. There are 4 of them: scientific revolution, heliocentric, universal gravitation, and the scientific method. Remember, when you hear this sound, it means you just heard a vocabulary term.
All right, you guys, we've got a big idea as well. The big idea for this particular unit is revolutionary ideas have a continued impact on societies and government. And a couple of essential questions. The first one is, do ideas from the past shape the present?
And the other essential question, how did the Enlightenment have long-lasting effects on people's ideas about government, economics, and society?
All right, you guys, the first section is called New Scientific Theories. You can follow along on pages 503 and 504. Be thinking of this question as you're listening. What new ideas did scientists develop? During the late Middle Ages, humanism started to influence scholars. Eventually, they began to question classical scientific ideas and Christian beliefs. This new spirit of questioning the accepted views of the world became known as the scientific revolution.
In the 1500s, scholars began to look at old scientific beliefs in a different way. A Polish astronomer named Nicholas Copernicus challenged Ptolemy's geocentric theory. Copernicus reasoned that the stars, Earth, and other planets revolved around the sun. This view is called heliocentric, or sun-centered. A German astronomer named Johannes Kepler later used mathematical laws to prove Copernicus's theory.
The Italian scientist Galileo made many scientific advances. These advances challenged classical ideas. For example, some of Galileo's findings supported Copernicus's ideas. But Copernicus's view went against official church beliefs, and as a result, church leaders forced Galileo to publicly declare that Copernicus's ideas were false.
In the late 1600s, the English scientist Sir Isaac Newton formed a new theory. This theory stated that all physical objects were affected by the same force, gravity. This natural force tends to draw objects toward each other. Newton believed that gravity acts on all objects throughout the universe. Because of this, he called his theory the law of universal gravitation.
In 1628, the English physician William Harvey published a work about blood circulation. He accurately described how blood circulates or moves through the body. Should be able to answer this question, you guys. How did Copernicus's view of the universe differ from Ptolemy's?
Our next section is New Scientific Inventions. You can follow this in the old textbook on page 505. The question you should be thinking about: what new inventions help scientists make more precise observations and measurements? In the 1670s, the Dutchman Anton van Leeuwenhoek built a microscope. Using the instrument, Leeuwenhoek saw a tiny moving matter in fluids. This matter he called bacteria.
In the early 1600s, Galileo invented the thermometer. This instrument measures changes in temperature. About 100 years later, the German scientist Gabriel Fahrenheit made the first thermometer that used mercury. He also created the first formal temperature measurement system. I know, I'll just let you guys know, next year when you're in 8th grade, one of your 8th grade science projects is usually making a Galileo thermometer. So you get an opportunity to be able to do that in 8th grade science.
In 1643, Evangelista Torricelli invented the barometer. This instrument measures the pressure of the Earth's atmosphere. Later, scientists used the barometer to predict the weather. The question you guys should be able to answer right now: why might instruments such as the microscope and thermometer be useful to scientists?
All right, the final little section, you guys, is called the scientific method. You can find this on pages 506 and 7. And think of this: what new ways of viewing the universe did philosophers propose? Frenchman René Descartes believed in questioning long-held beliefs. He also believed that every idea should be doubted until it had been proved through reason. Descartes argued that God created 2 realities. The first was physical reality. The other was the mind, or what people think. Descartes claimed that people should use their rational mind to understand the physical world.
The Englishman Sir Francis Bacon also believed in using rational, organized thought. But Bacon did not believe in using abstract reasoning to understand the world. Instead, he felt that scientists should use experiments and observation. This approach, called the scientific method, has specific steps. First, observing and describing a subject. Second, forming a hypothesis, an unproved belief about the subject. Third, testing the hypothesis in an experiment. And lastly, interpreting results to draw a conclusion.
The ideas of Descartes and Bacon became known as scientific rationalism. The influence of scientific rationalism began to weaken the power of the church. This started to happen by the 1700s. Why did this happen? Scientific rationalism encouraged people to think for themselves. Before this, people relied more on the views of the church.
Some political thinkers applied scientific rationalism to government. For example, John Locke believed people had the natural ability to be in charge of their own affairs. He viewed this ability as a natural law or right. Such beliefs led to the development of democracies in nations like the United States. All right, guys, the question you should be able to answer right now: what are the 4 steps involved in the scientific method?
All right, you guys, like always, there's going to be a podcast quiz. So here are those terms one more time for you. You need to be familiar with scientific revolution, heliocentric, universal gravitation, and scientific method. Goodbye forever.
Congrats. Woo!
We're done.